Okay, so good afternoon, everyone. I welcome you back to my YouTube channel, and presenting before you this tutorial is Hampel Kleeman. So, of course, today we'll be learning physics, particularly dimensional analysis, and I'm going to make this particular topic simple so that you may be able to understand what really dimensional analysis is all about. Okay, so this is one of the simplest first topics in physics, A levels. That is physics 101, can be any physics that you can attempt, because it's very important that you get to know this particular topic, because you have to know the significance of getting to know the reality that is behind every particular formula. There are certain formulas that may not hold in physics, and there are formulas that may hold. So you need to know which formula is true, which formula is not true, because there are formulas that you might have used maybe secondary school, maybe junior level, A level, and then they might not be able to hold at this particular level. Okay, so in physics, the word dimension simply denotes the physical nature of a particular quantity that you might be dealing with. Okay, so there are basic symbols that we use to signify dimensional analysis. And you are supposed to know these symbols in order for you to make your work very easy for yourself. Okay, so for this topic to be simple, you ought to know the symbols which I will highlight. Okay, now when we say dimensions of length, what do we mean? Okay, what are the dimensions of length? Okay, now the dimensions of length are simply, I'll put the brackets, then I'll write letter L like that. That is how I express the dimensions of length. What are the dimensions of mass? The dimensions of mass is simply big letter M. Just like that. Those are the dimensions of mass. What are the dimensions of time? We know that time is measured in seconds. Henceforth, the dimensions of time will simply be seconds, like that. Okay, even period, the same concept holds. What are the dimensions of formula of pressure? Okay, what are the dimensions? So you are supposed to know how to come up with these things. Okay, you are supposed to know how to come up with these things. Okay, so we shall know how to come about them, especially in the next topic, in the next segment of a video that I'm going to make. Okay, so the dimensions of pressure is simply some mass 1 multiplied by some length. Okay, some length like that. Then you have some period. Okay, some period that is raised to the power 2. What are the dimensions of force? The dimensions of force is simply the mass, the dimensions of mass, which is letter M, then the dimensions of length, which is a big letter L, and the dimensions of time, okay, which is big letter T squared. Now you may ask me, how did you come up with the dimensions for force? Well, let me show you something. We know that force is equal to mass multiplied by the acceleration. But we know that the dimensions of mass is equal to big letter M. What are the dimensions of acceleration? Acceleration has got the units meters per second squared. So I'm showing you how to come up with dimensions the easy way. We know that the dimensions for mass is simply big letter M. The dimensions for second, for time, okay, the dimensions for time, I think I forgot, the dimensions for time is simply big letter T. Just put T for the period, okay? Just put T for the period. okay, a big letter T for the period. So these are the dimensions for mass, okay. How about the dimensions for seconds or time? We know that time is measured in seconds. Of course, we are going to put a big letter T to the power 2 like that. So this is the same as if we replace in the formula acceleration in terms of dimensions. While there is m, I'll put the dimension of mass, which is big letter M. And then while there is second, I'm going to put okay, just a minute. Meters per second rather. So it was meters per second. Okay. Acceleration is equal to, the units are meters per second. Meters per second. But then we know that the dimensions for, okay, so I've already highlighted the dimensions for mass, but I now want to do for acceleration. Acceleration is meters per second. This meter is not for the mass, it's for the distance. What are the dimensions for length or distance? Okay, so this one is a meter, hence it's going to be measured in it's a measurement for the length, okay? It's a measurement for the length. As long as you're dealing with length, height, as long as it's a distance, know that the dimensions is simply L, okay, like we stated here. Then second is the time, okay? Second is the time, but we know that this is meters per second squared. So second is the time, so we're going to put, what are the dimensions for time? We say that it is simply big letter T for the period. Then we know that there is a power 2 there, so it will be like that. Now we replace everything in the formula. So this is going to be acceleration is equal to the dimensions of meters as simply letter L. The dimensions of time, which is second, is simply big letter T. Then if we get everything we have here, we replace it while there is acceleration. We are going to have the force equal to, we say that the dimensions of M is simply here, it is big letter M. Then the dimensions of, this is supposed to be negative 2. The dimensions of acceleration is simply L, then T. I put a negative 2 to show you that it was a ratio. Okay, so this is how they were able to come up with this particular formula. You can do the same for pressure and it will be able to hold. We go to the next part. So you use the concept of algebra to conduct easy dimensional analysis. Get that point, but we shall be able to use it in later questions. Please understand what I am doing. Write down the dimensions of the following. So we have been given the length. What are the dimensions of length? Well, the dimensions of length are simply big letter L like that. Okay? Big letter L. The dimensions of acceleration, we know that acceleration is equal to meters per second squared. Okay? Then we know that the dimension of a meter measures the distance or some length, then that is going to be big letter L. Then we know that the dimensions of some S representing the time, that is going to be big letter T for the period, and of course that becomes square like that. Okay, then we can replace in, henceforth we have found that the dimensions for acceleration, okay, while there is the meter, I'll put big letter L over, while there is the time for the second, I'll put big letter T to the power 2. And these are the dimensions of acceleration. Take note. Okay. What are the dimensions of displacement? Displacement is simply some distance. Henceforth, the dimensions of displacement are simply big letter L. Okay. So big letter L. How about velocity? How about velocity? What are the dimensions of velocity? Velocity is measured in meters per second. The dimensions for the meter, I had already stated that it is simply L, and the dimensions for the second, I had already stated that it is simply T. Okay? Now, because we don't have a power 2, it will just be T like that. Henceforth, velocity, in terms of finding its dimensions, is going where there is the meter, I'm going to put my L, and then where there is the second, I'll put my T. So, in other words, if you just remove the power 2, you found the dimensions of length. That was very, very simple. The whole essence of dimensional analysis is to prove that a particular formula that you are dealing with holds. Okay? That is the whole essence of dimensional analysis. Let's try some practice questions. Prove that the expression V is equal to V initial plus AT is dimensionally correct, where V and V initial represent velocities. A is the acceleration and T is the time period. So what I'm going to do, I'm going to get that formula. So the formula that we were given is simply, V is equal to V initial plus AT. We want to prove whether this particular formula is dimensionally correct. So we are going to write the data here. Okay? We are going to write the data here. What are the dimensions? What are the dimensions of velocity? Well, I think we had highlighted them. The dimensions of velocity is simply some L over some T. Okay, we know how to find that. This is velocity final. What are the dimensions of velocity initial? The dimensions of velocity initial are simply L over T. It's just the same. What are the dimensions of acceleration? The dimensions of acceleration are simply, this is just L over T to the power 2. And this is very much correct because I had shown you how to come up with the dimensions for acceleration. Okay, I already showed you how to find the dimensions for acceleration, and that is very, very simple. Okay, so now let's come up with the dimensions for time. Okay, let's come up with the dimensions for time. Okay, now having noted this, we can now prove whether this particular formula is very much correct. That is the whole essence of dimension. Very simple topic. That is the whole essence of dimensional analysis, to prove that a particular given formula holds. So what are the dimensions of velocity? The dimensions of V are simply L over T. So to know that this formula holds, we are supposed to prove that what is on the right hand side and what is on the left hand side is dimensionally the same. If it is the same, then it will be dimensionally correct. Okay, so what are the dimensions of V initial? It is simply L over T plus what are the dimensions of acceleration? It's just L over T power 2 multiplied by the dimensions of time. It's a period, of course. I forgot. The dimensions of time is simply big letter T, and I'll put my big letter T here. So we know that this and that guy can cancel, and we're going to have L over T equal to L over T plus, we're going to remain with L over T. Have you noticed that what is on the right hand side and what is on the left hand side is the same? Henceforth, we have proved that this particular formula is dimensionally correct. Okay, that is how you prove the first question. Let's come to the second question. They're saying prove that the period of a pendulum given by the formula below is dimensionally correct. Okay, so we have been given the second question, which I can copy, and I'm going to use another pen. Okay, I'll use another pen. So this one is saying that the period t is equal to 2 pi. Okay, then the square root of L over G. Now, under dimensional analysis, please take note, constants are never counted. So this is a constant, it's a figure, it's a number, henceforth we won't count it. So the only thing we are figuring for on dimensional analysis here is simply the period, okay, the period and the square root of L over G. We need to prove that what is on the right hand side and on the left hand side are the same. So what we are going to do is this. What are the dimensions of t? We know that the dimension of period are simply period. Henceforth, I will have my period here equal to. Then we have the square root on the right hand side of L over G. What are the dimensions of L? We know that the dimensions of length are simply length itself. Okay? What are the dimensions of G? G is the acceleration due to gravity, and it is measured in meters per second. Okay, so this same as acceleration, except it's just the same as acceleration. It will be measured in meters per second. So this is meters per second, and of course I already showed you at the end of it all we are going to have L over t squared. And of course, if I put it in my square root, I'm going to have L there, L, then over L over t squared. Then this is just the same as L over 1 multiplied by t power 2 over L. So this and this can cancel, and I'm going to have t to the power 2, of which this can cancel, and I'll remain with t. Henceforth, I'll have my t here, and I can say that this formula is dimensionally correct. Henceforth, this formula is dimensionally correct. Like that, very simple. Which other one do I have? All right, so a shape that covers an area A has a significant height h, and it has a volume of that. Show that that is dimensionally correct. You can even use units to prove dimensional analysis. They say that the volume is equal to A h, where A is the formula. So we know that volume is measured in centimeters cubed. Okay. Then this side, we know that we can also get the units for area. The units for area is simply centimeters squared. So I can put centimeters squared where there is area. Then the units for height is simply a meter. Therefore, I can put a m where there is h there. Then at the end of it all, even the units can tell me that this formula is going to be dimensionally correct. Okay? Henceforth, you say that is dimensionally correct. The formula is very much correct and it holds. It can be used for many concepts. We go to the last question. They're saying each of the following equations was given by a student during an examination. Prove that the following is dimensionally correct. So we have the first one here. So the first one is saying that we have 1 over 2 m2 equal to 1 over 2 mvo plus. So no matter how long the question is, do not be afraid to solve it. These things are very simple to do. All right, so dimensions, I already mentioned that constants are never considered, so we remove that. Henceforth, we will remain with only mv power 2 equal to mv, that is velocity initial, plus root of mgh. Want to prove, so what are the dimensions of, okay, what are the dimensions of mass? The dimensions of mass are simply m. What are the dimensions of velocity? We already mentioned that the dimensions of, okay, let me start with mass. The dimensions of mass are simply big letter M. Dimensions of velocity, okay, squared. We had already mentioned that velocity is simply L over T. L over T, since it will be power 2, so meaning the T can have a power 2, L is going to have power 2. What are the dimensions of mass? We have the same. Okay, then we come to gravity. Gravity, the dimensions are simply L over T power 2. The dimensions of height are simply L, like that. Okay, so this is V final. Dimensions of V initial are simply, okay, this is also going to be L over T power 2. We get back to our equation. The dimensions of M is simply big letter M, like that. Dimensions of velocity, we are going to have L over T power 2 equal to, while there is mass, I'm going to put my mass like that. Then here I'll put L over T power 2, but this is the initial, plus, then I'll get this, my square root. The dimensions of mass is simply big letter M. The dimensions of gravity is simply L over T power 2. The dimensions of H is simply L, like that. Okay, it's simply L like that. Now, what is going to happen is this. This is just the same as M L 2 over T2 equal to, this is going to be M L2 T2 initial plus, now look at this, this L and that L can multiply. We can end up having something like M L2 T2. But notice what will happen here. We are going to have M L2 T2 equal to M L2 T2 initial plus these 2 and that 2 and that square root can go, but we shall have the square root of M, then everything outside will be L over T. Now check what is on the right hand side and what is on the left hand side. They are very much opposite. Henceforth, I will say that this formula is dimensionally incorrect. Thank you so much for watching. Don't forget to subscribe, hitting the like button, and also sharing to others. This is just how you do dimensional analysis the easy way. Thank you so much.